Hello again. How are you? Um, yep, this is another stream. The last stream we had some issues. I think I figured it out. At some point, my bitrate for upload is super high. I suspect it's because I was trying to use the my Audio Technica microphone, which is not new, but it's new to this stream setup. And I probably should have mix the audio into a mono stream, but I didn't. That's probably why it's uploading a ton of audios. But now I started talking, and it looks like the bitrate is going up, but at least we're not losing frames on stream, which is great. Anyways, I'm going to resume what we started last time. Let me just take a look at my positioning the camera. Oh, by the way, since we're talking about stream, you'll notice the lighting is slightly better than last couple of things, because it is, and it's gonna get even better. And the microphone will be back as well. Okay, so the last time we stopped at having sketched out a implementation for TOML decoder. As you can see, we have a decoder. It has an interface that's called decode. You give it your metatype and the actual bytes. You actually do get a implementation that conforms to the decoder protocol from the standard library. If you have that, then all these other types falls out, because by requirement of the interface for the decoder protocol, you need to have a key decoding container, you need to have a on-key decoding container, and you need to have a single value decoding container. So we've stopped everything out. You'll see there's tons of repetitive methods, and they're stubbed out and with fatal errors. So I guess to start, we will, what should we do to start? Let's go ahead and implement some things. Wait, let's take an example. So the input right now is a dictionary with key A and value int64. So it doesn't matter what we pass in. So if I do TOML decoder, the user, and then when I say decode int64.self from this data, and I put try, it should fatal error, I believe. It threw the error. And the reason it threw the error is because onbox will always return nil. So I guess we can start with onbox. And we're not going to blindly implement it. And instead, we're going to try to copy it from JSON decoder. So the actual implementation in JSON decoder is a type called dunder JSON decoder. I guess at some point you'll get onbox. In 64. Yep, onbox as int64 is a method that exists and is part of the extension. I think, as we discussed last time, all it does is check against null, which we don't have to worry about. It do a bunch of NS number stuff, and then it returns, right? Essentially, it just casts. So if we so put it in an extension as well. Value will be any. The implementation could be as easy, as simple as I think. Well, we don't need to do self.value because value is passed in. Now, decoder unbox top. So this still doesn't seem right because at some point we need to say I guess we should never expect from here to do something like this. My value, this is pretty awesome actually. I can say this is a codable. And then I'll say I have A, which is int64. Say, give me my value. So bad still gets triggered here. Which probably means the generic version is getting triggered. Generic version, this is getting triggered. Yep. You can see the log I just added. So that means this guy needs to somehow call this guy. So let's look at that. At some point, one of these generic ones will show up. I think we're almost there. Okay, it's this guy. Yeah, so it calls another thing that mutually recurs. So what needs to happen first is we give it the dictionary, right? So we first need to somehow get the keys. Key value in dict. Is this what's needed here? JSON key. Let's look at how this is being. Aha. Okay, let's take a closer look at the unbox method. So unbox it. I wonder if this is getting triggered when that's getting called, or this guy. If it's this guy, it's a bunch of unitary type. Let's look at what is JSON string dictionary decodable marker. JSON string dictionary decodable marker is an internal protocol, and it basically key is string and value is decodable. Then its element type. Interesting. Do we need this? We may need this. Determine whether a value is string keyed dictionary containing decodable values. The marker protocol also provides access to the type of decodable which is needed for the implementation of the key conversion strategy exemption. Interesting. Okay, let's restart. Let's think about what we're doing here. So we have a value and its key will be the string A, and its value is going to be int64 number, and we're asking the decoder to decode it for us, right? So if this was a JSON decoder, what would happen? Let's go from there. Attempt to convert the data into a top-level object. In our case, it's going to be a dictionary, which is also hard-coded, no problem. And then we will create a JSON decoder referencing the top-level object with the option being that. And we do the same thing, don't we? We do create a decoder and decoder.ops. I guess whatever happens, the decoder's initialization hasn't happened yet. That's why we keep getting bad. So in the initializer here, we set up a storage. We push onto the stack our container. In this case, it's going to be a dictionary, I think empty. And then decoding is unbox is called. Unbox. Okay, we're back to unbox. unbox forwards to unbox underscore. Unbox underscore has a set of special things for some types before it actually finds the aha. So if none of these special types is recognized, unbox, it will do the following. It will push the container. It will pop the container when it's done. And then it will ask the type to initialize from itself. Great. Now I think we finally trigger the chain reaction, because now we can look at line 121, because whatever that is happening next. Line 121, we're decoding indexable type from key key. Yes, that's more like it. And this would be the key coding container. Let's look at decode paren underscore type int. Ah, beautiful. So in the keyed container, we know that the container is a dictionary. We know the key. Well, I'm not sure about this string value part. String value. Okay, I guess it's part of the protocol. Okay. Guard let under this key, else we'll throw an error. Key not found. Now that we have the entry, we will self.decoder.coding path. We will append this key, and we will also remove last, which just means this coding path is also kind of a stack-like object. Now we'll ask the decoder to decode guard let value equals self.try self.decoder. Decoder, now that I got the value matched with the key, please unbox the entry, and explicitly I know that 4 makes sense. Otherwise, we will throw expected type. I guess I won't say too much. And then finally we return the we'll get, because unbox. Oh wait. Work? Oh, it worked. That's easy. So I guess we just need to do that. Where were we? We need to copy this implementation a few times. Quite a few times, actually. And that means we need to start throwing Let's look at decoding error. Decoding error. Where are they defined? It's not a struct. It's not a class. Decoding error is a built-in error in the standard library, so I can throw this. I can throw that. Awesome. So can I just throw this whole thing? No, not that easy, right? Error description of key. All right, this is the actual thing we can steal, I bet. So function in a very strange place. That's not great. A separate version of this? No. Error description of key. It has things to do with the strategy and blah, blah, blah. Okay. All right. All right. For now, I'm just going to do a straight description of the key. Perfect. Which is there. Does it use anything special? No, it doesn't. That's awesome. And now I can do a lot of stuff here. Anything special about int64 here? Int64 is used in one place. This is good. This is good. Okay, so copy this. Decode nil. Huh. So bool, string, double, float, int 60, int 8, int 16, int 32, unsigned int, unsigned 8, 16, 32, 64. Okay, for all these values, we're gonna go down one line. We're gonna delete a word. We're gonna paste in the things we copied, and then we're gonna come all the way back up, go to the end of the line, go back one word, copy it, come down, go back to the end of the line, and then jump back a few words, delete a word, paste a word. So with that, I mean, decode for nil, we know it is always false, so we can implement that as well. With that, we have suddenly implemented a whole bunch of stuff, which means I can now have, well, this is tricky because the container actually needs to be a real value. But if I say like B is true, wait. Okay, B is true. And here I say b is a bool. We should get the value. Nope. Line 426. 426. Value decoding container. Why is it calling here, but the first time it did not? Why was that? Anyways, this part seems easy. Single value decoding container. It decodes a type. Where does it get the type? I'm assuming it's stack. All right. Let's look at the JSON implementation. Bool. So this is unkeyed. This is not the one I want. Yeah, this one. Expect not null, whatever that is. And then we call unbox as bool. So can I call this right here? Unbox self.storage top container. No mystery there. I guess it's the top of the stack as bool. And it's force unwrapped. Now where we are. Did we actually finish the parsing? Nope, we're in a infinite loop. Okay. So self unbox will push the value on top of the container again, and then we'll try to ask bool to do itself. I see. This is where those unloads comes in. Value any. Yeah, there's a ton of things like this that we need to define. So all these things are doing is like check whether the value is null, do the NS number stuff. In this case, it happens to compare the two core foundation constants. If they are the same, you return the corresponding value. For integer, it's probably simpler because it's like it's a NS number. Then you take the int, you do the length, and then you return the int. For us, it won't be that complex because we don't have to deal with things like NS number. But we need to come up with a way to deal with int64 to all these numbers conversion. Well, first I need to find my own unbox method. Okay. Yeah, we already have int64. We just need to do the same thing for bool. I guess that was the missing piece. So now instead of falling onto that generic version, and hopefully that will kill that infinite loop. And my value, that looks good. And towards the end, of course, we do get the my value. Okay. All right, so my takeaway from that is we need one of those things for each of these built-in types. By one of those things, I mean unbox. Right. We're gonna do string. We're gonna do double. We're gonna do float. Do int 8, 16, 32. Already have 64. Unsigned int 8, 16, 4. I'm not sure what's going to happen here, but I'm going to say start by copy. I guess this is a very different mentality than using them. I guess this is the Emacs mentality. I'm going to paste this whole thing here. Now I'm going to use multi-cursor to select each one of them. Hopefully I didn't miss any. Mark here. Move a few words back. Delete a word. Delete a word. Delete a word. Delete a space. Delete a comma. Move a word back. Another word back. Another word back. And start typing value colon any comma as type. And come one line down, go all the way to the beginning. Uh-oh, that's not good. Okay, we actually, this is pretty amazing. We got our cursor back. Now I just need to make sure I figure out this part. Can I do this? No, that's the wrong thing. So maybe I can go to end of this line, delete the whole line. Come one line down, end of line, beginning of line, end of line, beginning of line. And oh, this is what I needed. Duh. Oh, almost there, almost there. Copy, come down, as question type. So that's rather dumb. That's rather dumb. Hopefully there's a simplified. I'm just not thinking just through the call sequences in JSON decoder, which is supposed to be way more complex. So we know if we if I say here's 64, right? And then this is gonna be, I mean, let's say unsigned int 8. Oh, 526. 526. Decode unsigned int 8. Oh. Oh. Okay. Multi-cursor. Calm down. Delete that word. Pasting this word. Delete that line. Come up. Copy. Come down. And now that should work now, right? Uh-oh, infinite recursion. Why is that? Does this help? Cursing. Okay. So unbox of int 8. It didn't call into this guy for some reason. Oh, forgot to rename these functions. How about now? I guess I got a few conflicts up there. I bet one is for conflicting with these 4. For perfect. And that worked. And I think the fact that I casted it doesn't matter. I don't need to do this, right? Value not found. What about int 16? Yeah, I guess this is not very flexible. If you have an integer and it's gonna fail, which is not bad, not necessarily bad. Okay. So I know that's an integer. Now this should succeed. No? Oh, it's in 64. This was, oh, by 64 I mean 16. Okay, okay. So we've covered quite a bit now. We can unpack all the integers, which is pretty cool. Okay, I think we will actually this guy and make sure that we don't forget to delete it. And in here, we're gonna straight up pass in the top level object. And we don't need the bytes thing anymore. We don't need the where constraints anymore. And everything is good. I have no idea how this would succeed. This would be succeeding. Oh, because it's calling into this version. Take 0, put it down here. It should work as well. Yep, but now the difference being we can directly change things here and see it happen without scrolling up and down. That's much, much nicer. So the next interesting thing is this, right? If I say this is an array, and I make this value also an array, things will be really bad. Yeah. So line 361. So this is, I presume, an unkeyed decoder. Keyed decoding. And we landed onto this guy, which is a generic version of decode. Okay, let's look. Decode T. The fact that I can find all the answers I need for this implementation just tells you there's a lot of opportunity to reuse code. I bet if carefully engineered, like there should be a version of decoder that you can use to decode all kinds of things without writing much code at all. But that's out of the scope of this project, I suppose. This is keyed decoding container. Okay, which is the underscore JSON key decoding container, and here decode method that's generic, hopefully. All right, so decode container generic. What does it do? First, it gets the value from the key, by the key. It does all the coding path manipulation, and then the call onbox as type. Oh, what? So it's exactly the same. Except type is not going to be int64. It's going to be a variable. Okay, new fatal error. Line 476. 476. Decode type. Unkeyed decoding container. Here we go. I believe unkeyed decoding container. All right, let's look. JSON unkeyed decoding container. All right, it's implemented here. There's gonna be a large swath of things that's repetitive. All right, so let's look at how you get a bool from an unkeyed container. We first check whether we're inbound, whether we are at the end of the container. We push on the key value into the coding path, which I guess is wrapped because it's an integer instead of a string. Self-container is a list, so we now can access the value with current index, and then we unbox it. Makes sense. And then we throw an error, and that's makes total sense. Dare I do it? Let's do it. Guard self though is at end. Decoding error. Type. Decoding error. Context. Coding path. Actually, why am I typing this? Now this will give us error because we don't have the thing called JSON key, which is perfect because that's what we need to make. And we can look at the definition of JSON key. That is enum, right? No, struct. the struct, confirms the coding key, has a string value, int value, oh, both. Oh, I remember this now. Interesting. I remember this as a user. I remember this part. The key, the integer key is more efficient, but it's optional. Yeah. So TOML key, and this is a TOML key. And now we go back to the occurrence of JSON key. Change the word. All right, back to business. This is the unkeyed decoding container. This is where we were. We call decoder. Tell decoder where we are. TOML key. It's gonna be index. This guy. And what else other than self.currentIndex? And then we undo this with a defer. Okay. And then we have a whole bunch of stuff to copy. I thought I would type them all to get a better understanding, but I don't think I'm getting any better. Okay, I already kind of have a understanding of it. 488 is the generic version of this. I guess before I get there, I will do the mass editing once more. So wherever the type actually occurs, I need to replace it, which by the look of it is just this unbox line. By the look of it, yes. And now we go back to that line that was failing, 632. 632 is the generic version, right? 632. Okay, let's look at the generic version. Decode string, decodable. Wait. Super decoder. nested container. Decode T, where T is decodable. This is it. So we do the same thing with the boundary. Do everything else. I see. It's the same, except you don't say specific type, you say the variable. And that will forward us into a different piece of logic. Or not. Huh. AC, DC. This will work as well, right? This will keep working, please. Okay, it worked. Interesting. I feel like I'm just copying an implementation of JSON decoder. There's nothing specific so far other than when it comes to complexity. But I feel like a lot of things are happening. Those are gone. If we search for the word fatal error, we'll find there's only 10 more left. I think at least this one, the key decoding. This one, it's probably computed value. Yeah, exactly. That's already there. So now we have 9 fatal errors. And they all has things to do with nesting, super decoding, things of such nature. All right, let's look at the nesting case. So we have a struct X. We declare it's being codable. We say it has a value and it's one of my value. This can trigger some fatal error. No. Oh yeah, because we're not taking anything from, that makes sense. So if I want value to be like this, and I want to take X, forgetting this. All right, now we can trigger some new fatal errors. Okay. Oh, so what's missing? Nested key. Nested on-key decoding container. Oh, I bet these are for the manual things. Those methods are probably used when you need to manually conform your type into decodable. This, I kind of want to guess how to implement this, right? There's a pattern here, for sure. Single value decoding container, you write a bunch of stuff. I bet like this. Sure enough, it's like that. I also suspicion. Do I actually need any of these? Because ultimately, it all calls onto unbox, unless I'm not thinking of some recursion. Oh, it does seem that way. Yeah. Okay, those specific dispatches are there because it's a terminal condition of some loops. Okay. Yeah, this is interesting. I'm not totally getting the big picture yet, but yet large swath of the thing is already working. As you can see, the JSON deserializer, and things are already use the decoder. That's pretty awesome. Also, why am I still going? Please. Okay. Let's make this nice for ourselves. Make it look like Lisp. All right. So I take a break. It is kind of late. Nested container. Nested key. Key returns a keyed encoding container. Let's look at what this is about. There is a method called converted. You convert the key. You're making a dictionary, but it's a mutable dictionary. And you take the value from your container by the key. Create a new container. I feel like this is one of those things where you have to worry about as mutable dictionary, where we don't have to. It's gonna be simpler when we do it. Let's look at the keyed container case. This is, I assume, the top level container. No, it's keyed decoding container. Oh, interesting. We haven't done any of this yet. Keyed encoding container. Oh, this is encode. Hold on. Decoding container. At the bottom of these repetitive methods is the thing we really want, such as this nested container, key container. You take your decoder, you take the key appended to the end, and then you may remove it. You take the value out of the container by the key, and you cast it as a dictionary. Oh, that makes sense. Yeah. Because what's happening here is your user is asking you manually for the nested container, expecting a container. You just literally you take out the value here, you return to them as a dictionary. That's essentially what's happening. This is beautiful. I can do this. Bam. Couple things here. The key description, fix it. JSON will have to become TOML. Type mismatch. So that's some extension I need to steal. Type mismatch is extension on coding error. Type description. All right, I'll just take this whole cell. I will not deal with NS number. Okay. And now we have the implementation for returning the nested container. Container is gonna be exactly the same, except you cast things as a any, right? It has to be. There's no other way. Where was I? All right. Let's just keep stealing. It's gonna be very, very similar. Yep, you cast into any, everything else is the same. No, the super encoder, super decoder business is a little weird. Super decoder. Why do I need a super decoder? Or maybe a valid answer is what it actually does. Don't worry about owned or unowned. This is going to be a TOML decoder implementation. Options is optional. Okay. NS null. Oh. Is this okay? I don't know if this is okay. And this guy simply calls self super decoder for key TOML key dot super. I saw that earlier as well, so I know it exists. And this guy is even simpler because key is provided for you, so you just call TOML key dot for key. All right. Oh, interesting. For some reason, missed one here. Multi-cursor miss. Oops. So we have these three. I bet they're in the onkeyed container. They belong on the onkeyed container. I really should use code folding better. I need to learn that. Fold. Fold everything. Beautiful. Fatal error. Fatal error. Fatal error. Okay, now we can focus on these three things. Oh. Okay, let me try to reason about this. So we are asking for a nested container when we're decoding an onkeyed, we're inside an array. So what's really required here? We probably need to pop in the key as the index as the key, defer the popping it out. We take the last value, cast it as an array. If it succeeds, we return. If it doesn't, we don't. And when by return, I mean we create a keyed decoding container from it. That has to be it. That there's no other way you can implement this. So let's scroll until we find the real implementation. Nested container, right? Yep, you take the index, you wrap it in a key, you append it to your code path, you defer and remove it when you're done. You check whether you are out of bound. You take it, check against null, again, not our problem. You cast, if it succeeds, you return. Exactly. Locally, I'm getting it. Big picture wise, I'm kind of getting it. This is going to be a TOML key. This is TOML. Don't have to worry about null, which is awesome. What else? Are those all warnings? So super decoder is asking for a decoder, and we return this with the value. Can I? Yeah, I'm gonna force unwrap. Actually, I'm gonna keep the comment and force unwrap. Okay, what a distraction. Distraction. Where was it? Fold. Command, control, arrow. Needle. Nested key controller is gonna be very, very similar. Very, very. I mean, nested on key container. So is null again. It. Okay, super decoder, super decoder. Because this time there's no key involved. So because it's an on-keyed container, so you don't have to reuse that where you hide it as a private. Options. Way. Oh, TOML decoder impl. Oh wow, okay. Fatal error. There's no more fatal error. We have eliminated all the stubs we put in earlier. That's awesome. We have no idea whether things are working other than some very, very simple cases. We'll have to dive. We still haven't, we have not tested. Yeah, we have not tested in the complex cases. we have not dealt with options, but I believe everything else is in place. We have not thought through whether how much foundation types we want to support, because a lot of these mechanisms are here to support foundation types. But since our decoder, our deserializer won't be part of foundation, it's not from part of foundation, so it does have less baggage, and we obviously need to really hook it up with the deserializer instead of using the stubbed versions. But overall, I feel like this is a pretty good progress for today. Oh, workspace. Fill in all stubs. What's in the workspace? ID, space checks, XE user. All right, I can deal with this. I think this is fine. This will be fine. Ladies and gents, that is it for this stream versus video. Again, this stream dropped 0 packet. An hour ago, I was dropping 80% of packets. So the lesson here is check your video, check your audio input before you start your stream. All right. Have a good